Okay, this is the approximate method. And here's our figure here. This is a 1050 here, and this is a 350 here. Doesn't look very clear. And we're going to have distances here of, let's see, it's going to be 15 here and 20 here. Feet, that is. And of course, these are pounds per foot, so. Okay. Now, what can we assume here? Well, we can assume that, just right off the bat, I'm going to say that MF is going to be the same as MG1, that MD is going to be the same as ME, and that MG2 is going to be the same as MH because of symmetry. You know, here and here, here and here. So now, what is the approximate method? So we've got this frame here, and it's going to have a shear moment diagram, and there's going to be a point on the shear moment diagram for this girder, DE, FG, and GH, where the moment will be 0. And where the moment will be 0, we can make that a pin. However, it's mostly going to be at like 0.1 of the length inward. So for right here, 0.1 of the length in, 0.1 of the length in, right on all these points, here, 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 and here, and also right there and right there. That's where all the moments will be 0. So let's take the lengths here. 0.1, 0.1 of 15, and of 20. And with some quick mental math, we can say this is going to be 1.5 and this is going to be 2.0. So that's our lengths here. So now we can split this up. We're going to have FG, or yes, FG here. And let's write DE here. And then let's write GH here. And these are going to represent the inward beams of the structure. And to like conveyor belt this, we're going to have reactions at the points here for all of these, and at the center for all of these as well, for evenly distributed loads. And what is this length going to be? Well, it's this center section here, so it's going to be the full length of 15 minus 1.5 times 2, because we're taking 1.5 from here and we're taking 1.5 from here. So 1.5 times 2 is 3, so 15 minus 3, we're getting a length of 12. So the length here is going to be 12. Same for this one, since it's the same length, taking the same amount off. And while we're at it, let's quickly find this. It's going to be 20 minus 2 times 2. So that's going to be 16. 20 times minus 4. Okay. Now that we have this, for this we have 350 pounds per foot times 12 foot, so 350. Let's make sure you can see that. 350 times 12, 420. And divide that by 2. 210 for these supports. For DE, it's going to be 1050 times 12, which is 12,600. Divided by 2 is going to be 6,300. For both of those supports. Sounds like my uncle's here. Ma. Let me check out the door. Pardon me. Window. Okay. Back to this. My apologies. So there now for this last one, it's going to be 350 times 16, which is going to be 5,600, and then 2,800 for both of these. And that looks, except for this one. Sorry, this should be 4,200. Okay, for sure it sounds like my uncle is outside. Hold on. I can't, I'm blocked in. Whatevs. So where were we? Okay, yes. Now let's look at the cut sections, these little sections here. And this will tell us what we actually need to know to solve this problem. Okay, we're gonna have a moment for each of these. A force here on the outside, a force at the center, and a force at the very end. Okay, sweet. And this here we can say is MF, MD, and MG. And that's what we want to find overall. But we can start with, let's see, this is going to be 350 times our full length of 15, which is going to be 5,250. This is going to be 350 times our length of 1.5, because remember, this is now 1.5 here. And this is now 2 here. So now This is 2100 right here. And why is this 2100? Because we take this right here, equal and opposite. When it's cut, it's up here. So we can actually do that really quickly for all of these. Ah, yes. Sorry. 5250 divided by 2. You take the full length of this, find the weight, and then the supports would be divided by 2. So that's actually 2625. And then, of course, this is going to be 525. And we can do the same for this. Right here we have a length of 15, except for this is 1050 times 15. Well, let's just do the moment here first. So we're going to have MF is equal to, what's 1.5 divided by 2? 0.75. 0.75 times our 525. Remember, this way is positive. Plus 1.5 times 2100. MD is here. .75. What's the weight here? It's going to be 1050 times the full length of 15 divided by 2. It's going to be 7875. Sorry, not up there. Right up here, 7875. And then same thing, 1050 times 1.5 is going to be 1575. So it's going to be 1575 plus 1.5 times 7875. Okay, sweet. So now we can say our MF is going to be equal to this. Our MD is going to be equal to this. And what's this going to be equal to? Let's see, 0.75 times 525 plus 1.5 times 2100. This is going to be 3543. And this one's going to be 0.75 times 1575 plus 1.5 times 7875, which is going to be 12993. These are really, really not great numbers. Not amazing numbers at all. Now on to the last one here. Here we have 350 times 20 divided by 2. It's going to be 3,500 on that support, and then 350 times 2 is going to be 700 right on that support. Positive moment for G. This is going to be 1 times 700 plus 2 times 2800. MG is going to be equal to 6,300. Okay. Hold on, this might be wrong here. 1050 times 15 divided by 2 is 7875. Yeah. Something just doesn't seem right about that. That shouldn't be that high. $6,300. Sorry, I put the wrong thing in. Okay, there we go. I knew that number was just not looking right. 10,631. Okay, now we can analyze the joints. Give me 1 second. Nah, never mind. Okay, we're trying to find this force here. Now we only know there's a force here at joint F. Nothing on the top, nothing on the side. We have something unknown here and something known here. So that's going to come down because this is going up on this side, the cut end. It's going to come down on this end because equal and opposite reaction. So this is going to be a right here 26, 25, which means it's going to come up here 26, 25 because there's only one unknown. It's going to just be the opposite of that. This moment is going this way, but when it touches this side, it's going to go this way. So draw the moment like this. 26, sorry, that's going to be 35, 43. Which means that it's going to be going, let's see, it's turning this way, it's going to turn that way, right into the other one right here, 35, 43. So if this was a column, it would look like this. Down, down, moment here, 26, 25, 26, 25, and then right here and here is going to be 35, 43, 35, 43. So that's what the column would look like, and this would be column FD. So now let's analyze joint D. That's joint F, this is joint D. We have something on top, on the side, and then below. Well, what's on top? Well, we know it's going to be this part right here, joint F, so that's actually going to be moving down, 26, 25, and it's going clockwise, so let's make it counterclockwise this way. $35, 43. Now we know this one right here is going to be joint DE. We've got a moment going this way. First off, that doesn't make any sense. This moment shouldn't be doing that. We know it should be turning this way. So when it's coming here, it should actually be looking down. Pointed like that. Okay, here we have DE. And it's going to be going this way. So here it's been going turning with this. And it's going up here, so it's coming down here, DE 78, 75. And this is going to be 10, 6, 31. So now, let's see. This is probably going to be going up since that's larger. No, these are both down, so that's definitely going up. So this is going to be 36, 43. Wouldn't that be a 35? I think it should be a 35, 43. Where did I get that from? $26.25. $26.25 down plus 78.75 down gives us 10,500 up. And for the moment, since these are both going this way, it's going to go counterclockwise like that. And it's going to be this 1061 plus, what's that, 35? Where did we get that 35 from? Up here? 35, 43. This moment's going to be 14,175. So we have MA and AY. AY is going to equal 10.5K. This one's going to equal 14.2K. That's MA and AY. See right there? Makes sense. Makes sense. Now let's do joint G. Something there. Something there. Something there. Okay, so what are we going to have here? We're going to have something down. Something down. What's going to be down here at G? FG 2625. We're going to have a moment. That's coming this way. That one's going to be coming this way. And if it's coming this way, then it's going to have to be going the other way. It's going to be coming this way. And this moment is going to be 35.43. And then we're going to have something coming up here. And it's going to see, that's right here, GH. 6,300. So here we have 35.43.75 plus 6,300. Here we're going to have 9,843.75. We have a moment here. What's this moment going to be? Well, let's figure out the direction. It's going to be coming this way. They're actually going to counteract each other right here, and this one's going to be GH. It's going to be 6,300. So we're going to have 6,300's there. The downward force here isn't 6,300, it's 3,500. So this is going to be actually 70.43. Which doesn't, because it's not 35, it's, oh my gosh, I did the moments. It's 26.25. 26.25 plus 3,500. Sorry, 6,125. Now the moments here are going to be this, but I think they're going to be subtracting. This and this, subtract. So here we're actually going to have a moment of here. We don't know this one. We do know this one. This is going to be D, E. We have a moment. It's coming up on this side. It's doing that. That's going to be 10,631 down 3,500. No, down 7,875. Right here, the top, we know it's going to be the opposite of this, 61.25, and then the moment is going to be this way, 27.56. Which means that we're going to have these two dueling it out. 10,631 plus that. We're going to have MB equals 78.74 or 7.9K. And BY is going to equal 61.25 plus 78.75, which is 14K. Okay. Lastly, we have joint H. Right here, joint H is just looks like this. Going down 3,500. Being rotated, it's going this way, but on this side it's going this way, so on this side it's going back that way. 6,300. This means that MC is going to be equal to 6.3K, and CY is going to equal 3.5K. So there you are. Hopefully this is all good. Let me check. AY 10.5. BY is 14. And this is 3.5. Yep. That's all correct. And now let's do the moments. Moment A is 14.2. Moment B is 7.9. And this is 6.3. Oh. Sorry. That's negative. And that's negative. My bad. So there you are.